Hi all, welcome to my YouTube channel, Know About Embedded System. So in today's video, we will understand one of the very important topic that's called as a PLL. So this PLL is used inside the microcontroller to generate the desired frequency for your microcontroller and also for CPU. So PLL, phase locked loop. So before starting the video, if you are a new viewer to my channel, kindly subscribe my YouTube channel and gain the knowledge on embedded system. Let us start the video here. PLL, phase locked loop. So before starting, so this is a simplified block diagram. This I'll explain later. So we will understand what is the need of PLL. Later I'll explain how it works. First we'll understand what is the need of PLL. So guys, consider two scenarios here. The scenario number 1 and the second one is the scenario number 2. In the scenario number 1, we're not using a PLL here. The microcontroller without PLL and second scenario with PLL. In case of first scenario without PLL, you can see here this is my microcontroller and this is my crystal oscillator. So crystal oscillator, let us assume this is going to operate in 12 megahertz and 12 megahertz whatever it is available in the crystal, the same 12 megahertz will be supplied to the microcontroller, and even the processor which is running inside the microcontroller, so that also should operate at 12 megahertz. So there is no choice. So 12 megahertz is a crystal and microcontroller and all peripherals also should work 12 megahertz or less than 12 megahertz, and even the processor which is sitting inside the microcontroller, that also should operate at 12 megahertz. So this is the scenario without PLL. Now let us go to the second scenario here with PLL. So now I have crystal oscillator here which is running at 12 megahertz and also I have PLL here, phase locked loop, and with the help of this PLL I'm able to generate a new different high frequencies. Example I'm considering here 12 megahertz, 24, 48, 96 and it goes on. So example purpose I have considered here, the PLL is able to generate up to 500 megahertz frequency. Okay, so what is the advantage of PLL here? PLL will generate very high frequencies which are required for microcontroller and the processors which is running inside the microcontroller. So microcontroller programmers can select which or what frequency you want to operate. If you want to operate lower frequency, then I'll go for 12 megahertz. If you want to operate at medium frequency, I'll go to 24. If you want to go for 48, yeah. If you want to operate at higher frequency, yes, you can go to 96 megahertz. So the choice will be given to the programmers according to the requirement of your project implementation. The programmers can select the operating frequency of your microprocessor and microcontroller with the help of PLL. So this is a very big advantage of PLL in the which is available inside the microcontroller. Okay, usually lower end microcontrollers like 8051 and most 8-bit microcontrollers will not have a PLL inside. If you want, we have to connect externally, or else we have to go for the microcontrollers which are based on ARM architecture. Okay, so now what is the purpose of microcontroller? I have already told what is the purpose of PLL inside the microcontroller. The first one is high frequency generation. It is possible to generate very high frequencies with a different values or with a different clock configuration. It is possible with a versatility. So it's possible to generate different clocks, right? The clock synchronization, with the help of this PLL, we're able to synchronize microprocessor, microcontroller and even peripherals with the help of PLL with a very high frequency, and as usual, so it is able to generate very high frequency. That's called frequency synthesis. I hope you understood what is the need of PLL. Okay, this already I have told you. I have already explained what is the role of PLL. So with the help of PLL, we're able to generate at different frequencies. In microcontroller, PLL plays a very important role. It's a kind of a feedback circuit which is able to generate a new frequency and stable frequency. It is possible to generate a new frequency. It is also possible to generate very high end and stable by taking the lower frequencies. So PLL is able to generate a very high end frequency by taking low frequency as an input. This is one of the beauty of your PLL. Supply 12 and you're able to generate up to 96. Example, I have considered up to 96, but it is possible to generate up to 400 to 500 megahertz. Since it is able to generate very high frequency, you can supply the clock to the CPUs, and also you can supply the clocks to the peripherals, and all the peripherals which are available inside the microcontroller, you can supply the clock from the PLL. Okay. Now, how it works. Simplified block diagram of PLL. You can see here the 5 important components of your PLL you're able to see on the screen. The first one is the input frequency, nothing but input clock. That is your crystal oscillator. Usually we will be using crystal oscillator either in a 12 megahertz or a 10 megahertz we will use. And the second important component is a phase detector. Third one is a low pass filter. Fourth one is a VCO or CCO. VCO stands for voltage controlled oscillator, or CCO is also called as current controlled oscillator. VCO stands for voltage controlled oscillator. CCO stands for current controlled oscillator. Okay. And then we have a divider here. We have a feedback path here, and also we're having one divider here. So this is a simplified block diagram of your PLL. Well, let us understand how it works, how the PLL works. So let us assume here we have a crystal oscillator and input frequency of 12 megahertz. Let us keep it here. So now what here is going to happen here is the input frequency will be given to the phase detector. So what is the role of phase detector? You might be knowing already. Phase detector is nothing but a circuit which will detect the phase difference between two different signals. Right? The phase detector is nothing but the circuit which is going to detect the phase difference between two different signals is called as phase detector. Okay, so input signal will be given to the phase detector. So here you can see there is no feedback initially. Since there is no feedback, obviously, so here you will be getting 0, and we have to consider delta F. So what your phase detector will do? Phase detector will consider the phase difference between two frequencies. So now since here there is no signal, so whatever the signal is applied with the phase, the complete phase will be given to the low pass filter, nothing but delta F, or sorry, delta phase, delta angle we will call, not the delta F. So we will take delta phase, delta phi we will call. The phase difference will be given to the low pass filter. So what this low pass filter will do? So low pass filter will consider only low frequency signals, nothing but the difference, delta differences it will consider, and according to the difference whatever we got, it is going to generate a new value or a new multiplication factor that is called as M here. With the help of the delta phase, whatever you got, the difference delta phase between two different signals, that is considered in a low pass filter, and a low pass filter will generate the equivalent voltage or equivalent multiplication factor, and that multiplication factor will be given to the VCO or CCO. So what is the VCO or CCO stands for? VCO or CCO stands for voltage controlled oscillator or a current controlled oscillator. Here whatever you got here, that is going to be converted either in the form of voltage, or you will be getting in the form of current. The output from the low pass filter will be in the form of voltage or in the form of current. Okay, so that output voltage or a current will be given to the VCO or CCO, and you know that VCO and CCO stands for voltage controlled oscillator and current controlled oscillator. So this voltage in turn will be acting as a multiplication factor. The voltage or current which is taken from the low pass filter is considered as a multiplication factor and will be applied to VCO CCO, and this VCO CCO is able to generate a new frequency signal with a new frequency, the sinusoidal signal with a new frequency. Okay, now the new frequency which is generated from the VCO CCO will be supplied to the dividing circuit with having some dividing factor, so that we were going to reduce the frequency and will be given to the phase detector again. So here we are getting a newly generated frequency signal, and here we are getting input signal. So like this, again the new cycle will start here. So input frequency, angle, and feedback signal, so both will be considered. Again the phase will be detected. So once the phase is detected, it will be passed to low pass filter. Low pass filter will generate a new voltage and current values, and that new voltage and current values will be considered as new multiplication factor, and this process will be continued. This will be continued and this will be continued until you are getting the phase is equal to 0. Whenever you are getting the phase difference between two signals is 0. So whenever you are getting a phase between input signal and feedback signal, so whenever you are getting the phase difference is 0, then the process will be stopped. So whenever you get a phase difference is equal to 0, then that is called as phase lock condition. That process is called, or that situation is called as phase lock condition. Whenever the phase difference between input signal and feedback signal is going to be 0, then that situation is called as phase lock condition. So once phase is locked, the new frequency will be locked. So new frequency will also locked. So whatever you are going to get a new frequency from the VCO and CCO, that also will be locked, and later PLL will be connected to microcontroller. So new frequency which is generated, that new frequency will be connected to the microcontroller, and inside it will be supplied to different peripherals and even to the CPU. So in this way it works. So we have crystal, phase detector, low pass filter, VCO and CCO. Okay. So this is your PLL. So I hope the PLL is clear to all. If you feel this video is an informative video, so please click on like button and subscribe my YouTube channel.